Unit 1, Part 2 is all about the foundational macroeconomic model, supply and demand. We're going to start with a simple supply and demand model in this unit. We're going to talk about demand in Module 5, supply in Module 6, and then we'll put them together in Module 7. When supply and demand come together, they create a model showing market behavior. So the first step is figuring out what a market is. A market is where buyers and sellers of particular goods come together. So maybe this is a market for strawberries. The buyers are people that control demand. These are consumers that are interested in buying strawberries. And then suppliers are the actual sellers, the growers of the strawberries themselves. They're going to control the supply line, and consumers control the demand line. The sellers are going to want as high a price as possible. The buyers are going to want the lowest price possible for each good. Where they meet in the middle of this market, that's going to create the actual market price. We've learned that you always have to make certain assumptions when learning economic models to kind of simplify what we're studying. So the first assumption for simple supply and demand is that the market is competitive. What a competitive market means is that there are lots of buyers and lots of sellers. Therefore, they're both competing with each other. If there's only one group of buyers, that's going to affect the price. So this could be something like the market for fighter jets, some sort of really expensive military equipment. If there's only a small amount of people that buy it, they're going to have a huge amount of influence over the product itself and how much they're willing to pay for it. That's going to throw things off. There's also situations where there's a limited number of sellers. So the very first tablets, I think when Apple iPad came up on the market, there weren't that many competitors. So it was not a competitive market. And if there's very few people selling it, they can have the price be really, really high. So in both those cases, if you have a limited number of buyers and sellers, the market is not competitive and it doesn't function normally. So we have to assume that wherever we're studying is a competitive market where buyers are competing with other buyers. If you won't pay that price, somebody else might. And sellers are competing with other sellers. If your quality is really bad, someone else might produce the good at a better quality. So if everyone is competing, this is going to have the market balance out and reach equilibrium. Now we're going to start focusing just on the demand side of supply and demand, and we'll start with the demand schedule. Demand schedules are these tables, and they give you a list of prices and tell you at each price point what is the amount demanded. So if price of ice cream cone was free, it is $0. A lot of people would want ice cream. So in this case, 12 people are demanding ice cream cones at $0. But as the price for ice cream gets more expensive, the price is going up from $5 to $10 to $15, the demand starts going down. The number of people that want it is decreasing. Finally, you'll reach a point where it's too expensive. So at $25, there are still 2 people who are saying, I really want ice cream and I have a lot of money. I personally think it's valuable, so I'll still pay for it. But you'll finally reach a price, in this case $30, where no one demands it. It is now too expensive. So when the price is low, demand is high. And generally speaking, as the price is increasing, the demand is decreasing. Do you see how these go in opposite directions? Lowest price, highest demand, highest price, lowest demand. These are inverses of each other. An inverse means they're opposites. So if price is going up and quantity is going down, that's an inverse. You have another example about a soda. And here we have a larger market. There's more people that apparently want soda that they're serving. So if soda is 25 cents, 890 people will demand the soda. As soda goes up in price, now it's $1, the demand has fallen to $4.70. When soda goes all the way up to $2.75, the demand has fallen to $100. And eventually we would reach a price where no one is willing to buy soda. So you can see in both of these examples, when the price goes up, the quantity demanded goes down. Now that you've seen how demand schedules work, we're going to start plotting a demand schedule onto a demand curve. So in this case, we have price, and in supply and demand, you always have price on this axis. Now before, with PPCs, you learned that you can put either good on either side, and that was only true for PPCs. For supply and demand, there's very specific locations where everything goes, so we want to make sure that we're doing it correctly. So price always goes on the y-axis, and quantity always goes on the x-axis. So we have quantity there, and this QD stands for quantity demanded. Okay, so we're just plugging in those points on the model here. So if the price is $5, so we have $5, the quantity is 50. So you find $5 for price, quantity is 50. Go ahead and you put the dot where they intersect. And then $4, 100 is demanded, so you follow along $4, 100, draw the point. Sorry, that's a little messy. So that's basically how it's plotted, that each of these points is a point on the demand schedule. Once they're all plotted, you connect the dots, draw the straight line, and that's what gives us this thing. It's called a demand curve, even though it's a straight line. Don't let that throw you off. Some demand curves are more straight, some of them are more curved. It doesn't really matter in this case. The point is that it's downward sloping. As the price goes down, the quantity demanded goes up. That's the only important thing about the shape for demand that we need to know. We were saying before how some demand curves are straight lined and some are more curved, but the most important factor is that it's downward sloping. So here's another example of this. We don't actually know what this good is, but it doesn't matter because it's following the laws of demand. As the price goes down, $8, $7, $6, $5, $4, and onward, the price is going down, the quantity demanded is going up. And that's being reflected on these points. It might not be a perfect straight line, but you can tell it's demand because as prices fall, quantity rises. Okay, so we're going to just focus on demand today, but I just want you to see where we're headed and how a supply and demand model works when all the pieces are put together. So the first piece is the demand curve. We're learning that today. Second piece will be the supply curve, and where the two intersect is called market equilibrium. Market equilibrium will give us both the equilibrium price and the equilibrium quantity. I'm going to show you on the next slide a larger picture of this so we can see these pieces in action. So demand and supply, where they meet, gives us equilibrium. So that's how it all starts. But then things are going to actually happen to this model. Something will cause the demand curve to shift or the supply curve to shift. Movement of the model is going to change equilibrium, because if one of those lines moves, equilibrium moves too. And that'll give us a new equilibrium price and equilibrium quantity. So now you have a larger model of supply and demand to see all of these pieces that we talked about. The first line is the line in blue that is labeled demand. We talked about how demand is always downward sloping, and you can see how this one is. This model, can you try to read it and determine what good we're talking about with this model? Okay, this one's for coffee beans. And sometimes you'll know because the good would be written on top. So it could say coffee beans above the top. But this one tells us on the axes where it says price of coffee beans and quantity of coffee beans. So it goes ahead and tells us the good in that section. As long as the good is labeled somewhere, that's okay. So as the price of coffee beans goes down, the quantity goes up. That's what we think should happen with demand. So here we have at $2, how many pounds, billions of pounds of coffee beans are demanded? So you look at $2, you follow it down, 7 billion pounds are demanded. That's kind of how that works. So that's demand. Supply is the line in red. We're going to learn supply in Module 6, but it is upward sloping. Supply is done by the people that are actually selling the coffee beans, and they like high prices. So as the price goes up, they want to supply more. So in this case, as the price goes up, their desire to supply coffee beans will rise. And as you can see, where the two meet is called equilibrium, and we're always going to label that with an E to show that it's equilibrium. So that's pretty straightforward. And you can see the equilibrium price. You just follow the E to the price axis, and that is $1. And equilibrium quantity is 10 billion pounds. And I'm getting the billion pounds because it tells me that here in the axes. So what this is saying is that suppliers would love to charge $2. Demanders would love to only have to pay 50 cents. But that's not going to work. Not everybody's going to get what they want. We're going to have to meet in the middle. So at $1, that's a little expensive. So demanders probably won't buy all the beans they possibly could. But suppliers also say, you know, I'd rather get paid more, so I won't supply all that I could. So where we meet in the middle will give us the equilibrium quantity too. This is all going to change. We're going to see a lot of practice with these things. This is kind of the introduction here. Let's say demand shifts. So now we have a demand 2. So demand 2, you're going to have a whole new equilibrium here. You would label that E2. And that will give you a new equilibrium price and a new equilibrium quantity. So we're going to learn how those shift in 7 when we put all the pieces together. We start with demand and not supply because you all are doing the demanding. You can relate to this. You are consumers. Anytime you've purchased a good, you've thought like a consumer. And normally consumers really care about price. They will only pay a high price if they really, really want something. That'll make their demand higher. So generally speaking, the higher the price, the lower the quantity demanded. So something that's a little bit more expensive, maybe like Starbucks coffee, the more expensive it is, the less you'll demand it. The less frequently you will buy that good. But if the price fell, the lower the price, the higher quantity demanded. When something goes on sale, you're more likely to purchase it if it's something that you're otherwise interested in. So if price is the only variable, higher the price, lower the demand, lower the price, higher the demand. And that makes demand curves downward sloping, which means there's a decreasing opportunity cost. As the price falls, so if we're going down, the price is falling, and the quantity is going up because this is 0. So anytime you're getting closer to 0, as the price is getting closer to 0, the quantity is getting further away. So this quantity has a lower price and a higher quantity. Price is even lower, even higher quantity still. Now that we've talked about demand quite a few times, let's see if it's really starting to stick. So here we have the law of demand. It's going to start with all other things equal, that Latin ceteris paribus phrase that we've discussed in Unit 1. So all other things equal, a higher price for a good or service leads to a blank in the quantity demanded. So if prices are going up, what's happening to the quantity of that good that you demand? It's going down, it's decreasing. So please go ahead and write the word decrease, but a down arrow works too, and it's very hard for me to draw, to write letters with these cursors when I'm making these videos, so I hope you don't mind the down arrow. So it's a decrease in quantity demanded when the price goes up. So if the price is going up and the quantity, see what I mean about the letters, and the quantity is going down, is that a direct relationship or an inverse relationship? That's an inverse relationship. So when one is going up and the other is going down, that is inverse. When we learned about supply, you'll see that in supply, when price goes up, the quantity goes up as well. That's a direct relationship. So learning these words, inverse and direct, are supposed to kind of help you as a shortcut to figure out if one's going up, what's happening to the other thing. With demand, it's inverse. When one goes up, the other goes down. Now that you have a good general idea of how the demand curve works, we're going to start doing things to it. The demand curve can be shifted, or there can be a move along the curve. If the demand curve is shifted, that means the entire line moves. So we're going to figure out how each of these directions works. I know that you have some questions in italics in your notes, and just an FYI about how italics work in the note guides. Anytime you see italics, normally that's something that is maybe not directly in the notes, but something that we're going to talk about, or something for you to pause, stop, and think about the right answer. So I'll go ahead and show you on the next slide the shifts to the right and the shift to the left, and talk about which direction is which. So just hold that thought. We'll come back to it. So if the demand curve is shifted, there was an external factor that did that, which means something outside of the model. So I mentioned before, we talked about models for coffee. We talked about models for strawberries. If something that is external affects those things. So it's not about the coffee or the price of the coffee. If it's something else, that's an external factor. That's going to make the entire line move. That will shift the curve. And if the entire line moves, we call that a change in demand. Now, there's only one thing that causes a movement along the curve, and that's a change in price. So if you have a change in price, you actually just make two dots on the exact same existing demand curve, and you draw an arrow showing which way that occurred, which way the price changed, and that will change the quantity demanded. So here I want us to start seeing a major difference that's very, very, very important. Change in demand versus change in quantity demanded. These are not the same thing. So change in demand means the line moved. Change in quantity demanded means you have the same line that you always had, but there's been a move along that line. So we're going to see these in the next slide. All right, we're going to use this visual to try to go through all of the italics. I might not go through all of them in the exact order. I don't have the notes in front of me, so I apologize for that. So we're going to use this visual to talk about shifts and move along the curves. So first of all, I just want to show you kind of generally speaking how this always works. So I want you to know that anytime we're at this point here, the corner of price and quantity, that's 0. So if price is going towards 0, it's decreasing. If quantity is going towards 0, it's decreasing. So they look like they're moving in different directions, but you're thinking about it in terms of, is it going towards 0 or away from 0? All right, so let's talk about our first major effect here. So we have demand curve D1. You can tell this is the original demand curve because it's labeled D1. The one is showing you that it came first. When the line moves, we have a D2. So you can also tell that it shifted to the right. The numbers went up and the arrow is pointing to the right. So this might seem a little bit redundant, but we always do both. We do a 2 on the second line, and we also do an arrow to show the direction of the shift. So in this case, we have a whole new demand curve. So demand shifted. This is a shift, not a move along the curve. And if demand shifted, is that a change in an external factor or a change in price? That's an external factor. And I'm going to give you a list of those things coming up. But generally speaking, this is not price. So from D1 to D2, our quantity demanded was here. It went to the right. So a right shift means that demand increased. Now, don't use the word quantity. Remember, we just learned there's a big difference between change in demand and change in quantity demanded. You only use the word quantity if you have a move along the curve. And we're looking at a shift. So a right shift means demand increased, period. Okay. Let's imagine that this was our D1 and this was our D2. And the arrow went this way, a left shift. Okay, so a left shift, are your lines getting closer or further away to zero? They're getting closer to zero. So a left shift means demand decreased. So right shift, demand increased. Left shift, demand decreased. That's all it is for shifts. It could shift further. We could have a whole nother D3. An arrow. It's still to the left. It still means the demand decreased. Okay, that's shifting. Now we're going to talk about move along the curve. So A to B is our example of a move along the curve. So what is the one thing that causes a move along the curve? A price shift. So from A to B, we're on the exact same line. We're on D1. That's why it's a move along the curve and not a shift. So the price was here and at A, and now it goes down. So from A to B, this is a move along the curve showing a decrease in price. And what happened to demand? Remember, if we're using a move along the curve, the answer has to be quantity demanded. So did the quantity demand go up or did the quantity demand go down? So look at it this way. This is A's quantity, this is B, so it's getting further away from zero. So the price decreased, but the quantity demanded increased. And that fits because with demand, it's always got to be that inverse relationship. Let's make up a whole nother example here. I'm going to do a point D. Why not? Any curve, you can have move along the curves. That's totally allowed. All right, so from C to D, we still have a move along the curve, but the price went from C to D. So the price increased. And what happened to the quantity demanded? It decreased. It's getting closer to zero. So when you have a move along the curve where price increases, the quantity demanded decreases. We'll practice this more, but this is the kind of thing that if you're not understanding this video, maybe rewind it, play it one more time. So you learned that price is the only thing that causes a move along the curve, but there's a whole slew of external factors that are going to shift demand. So we're going to kind of switch gears and focus primarily on demand shifts and all the different criteria that can shift demand. So anytime you see a change in demand, that means the demand shifted, the entire curve moved. And we've been hitting on this, but here it is again. D1, as you can see, is the original demand line. So from D1 to D2, we have a right shift, which is an increase in demand. So at any price, consumers would buy more. And we're going to talk about a lot of factors that would make the demand of something go up regardless of price. D3 is a left shift. This is showing a decrease in demand. So something is perhaps unpopular. We're going to find out other reasons why as well. For at any price, consumers would buy less if there is a left shift. Now we have the demand shifters. Every economic model that has shifts, I'm going to come up with a mnemonic device to help you keep straight which factors shift each line on that model. So merit is the mnemonic device for demand shifters. And we're going to practice this. You're going to practice identifying which category the shifter is and also what the effect would be on the model. Would it make it shift left or make it shift right? So the first category within merit, the M, is market size. So markets are about buyers and sellers. This is going to be the number of consumers for the good. So if there are a large number of people, if something happens to increase the number of people that want to buy your product, the market size goes up. That's going to increase your demand. I'm trying not to give away too many examples here, but just kind of introduce. Expectations, the E in merit, is a category related to the consumer expectations about price. Do we expect prices to change in the future? This is different from just price changing. Price changing is a move along the curve. But if you expect the price to change in the future, that is a different category. R stands for related prices. There's going to be two categories of related goods, complements and substitutes, and we'll go into detail about both of those things. Complements are and, these things go together. Substitutes are or, you would choose one or the other. I is income changes. So if the general income level in your nation goes up, people are going to purchase mostly normal goods. We'll talk about what that means. If the income level goes down in your nation, they're going to demand more inferior goods. And the last category is taste. This is really what's popular, what's trendy. If something is really, really popular, the demand for it's going to go up, and vice versa. So as long as you have merit all written out, we're going to go into detail about each of these shifters. So the M in merit was about market size, number of consumers. If the number of consumers for a product fell, what would happen to demand for that product? Just think about it. If fewer people want to buy that product, the number of consumers who buy it falls, the demand for that product would fall as well. It would decrease. Now I'm going to do those italic examples that you have on your notes. I went ahead and put them in here so that I would remember. Okay, what would happen to the demand for prescription drugs as the population grew older? So in that case, the market size is increasing. If we have more elderly people, the demand for prescription drugs would increase, right? Fair enough, simple enough. The next one, what would happen to the demand for infant formula if birth rates decrease? So we have fewer babies, and so the demand for infant formula would decrease. A lot of my students find that it's helpful for them to come up with kind of a shortcut on the side in their margin. So in this case, the relationship between the market size and demand. So here we have demand, and as the market size goes up, the overall demand goes up, right? So that makes this an inverse or a direct relationship. This is a direct relationship. And if the market size went down, the demand would go down. So either direction, it's going to be a direct relationship. More consumers, higher demand, totally makes sense. Expectations is a little bit more confusing because expectations sound like a change in price. But the difference is the price hasn't changed. You are expecting it to change. If prices go up, that's a move along the curve. But expecting prices to go up in the future, that's a shift. That's expectations. Now, you actually have a lot of these things in your life. Some of them you might be more aware of than others. So consumers just know that there's going to be sales at certain times of year. There's a lot of holiday sales. People know that, for example, school supplies are going to go on sale in August. Christmas decorations and Halloween candy are all going to go on sale right after the holiday. If you're trying to buy lawn equipment, it might be cheaper at the end of the summer. So there's all different types of things like this where people might know and expect certain things to go on sale, but you also expect certain things to be more expensive on certain times. So Memorial Day weekend and Labor Day weekend, gas prices shoot up. And a lot of times consumers know this, they expect it, they plan ahead. Flowers on Valentine's Day, the price goes up. And consumers are knowledgeable. We're on to these sort of things. So knowing that the price is going to change in the future, that's expectations. All right, so what would expecting a future drop in price due to current demand? So we're talking about our example right here. Okay, so this is saying you expect something to be cheaper, let's say, next week. So what happens to your demand for that product right now? So we have a future drop in price, but your current demand. So if it's going to go on sale in a week, what happens to your desire to buy it today? That goes down. So knowing the price change is coming affects your demand currently. We're going to go ahead and do the italic examples on the next slide. Now let's do some examples of expectations and also end with kind of a review of expectations and try to figure out if this is more on the inverse relationship or direct relationship side. So the first example, if I expect the price of an iPhone 5 to fall next month when the iPhone 6 is released, what happens to my demand for the iPhone 5 today? So if it's going to be cheaper in a month, my demand to buy it today goes down. And this happens with lots of products. So any technological releases, also new cars. So at the end of the model year, which ends up being more kind of August, September, October in the fall, when new cars are released, last year's cars go on sale. Consumers know it, and they're going to buy fewer cars right leading up to that until the prices actually decrease. Next example, if I expect the price of gas to increase over Labor Day weekend, what happens to my demand for gas a few days before? So you notice you're a little bit low and you know the price is going to go up in the future. Your demand to fill up that tank right now increases because you know that it will be more expensive in the future. So price is something that people think, oh, well, if I'm on empty, I have to pay for gas. Not necessarily. Your desire to fill up your tank or just buy a little bit of at a time is all directly related to price and your expectations of future prices. So here's kind of our general overview of expectations. If I expect prices to rise in the future, my current demand, if it's going to cost me more in the future, I want to buy it now before the price goes up. So expectations of future high prices are going to lead to current demand increases. And alternatively, if you expect prices to fall in the future, if you expect it to be on sale in the future, your current demand would decrease because you don't want to buy it now, you want to buy it later when it's cheaper, if at all possible. So this is direct expectations of a price increase leads to a current demand increase. Expectations of a price decrease lead to a current demand decrease. Now, this is not the way that actual price changes happen, because remember, if the price actually went up, your demand goes down. But expecting the price to go up makes demand go up in the meantime. So this is why expectations are different and they function differently than price, which is just a move along the curve. Expectations are a shifter. The R in merit stands for related goods or services. This is a pretty big category because it has two subcategories. We have substitute goods and complementary goods. A substitute good is something that you would buy instead of something else. So the key thing to think of is or. You will buy this or that. And the thing that's going to determine which good consumers buy is the price. So we're going to assume that Pepsi is a substitute for Coke. Now, you might personally feel like these aren't equal substitutes. I know I prefer Coke, but we have to think economically. And one of the assumptions that we've learned we have to make is all other things equal. So we're going to assume that Pepsi is equally as good as Coke and vice versa, and the only factor here is price. Okay, so if price is a substitute for Coke and the price of Pepsi rises, what happens to demand for Coke? It goes up, right? Because consumers want to buy the cheaper one. If they're both viewed as equally good and the price of the substitute goes up, the demand for the other good will go up because it's now cheaper. So if the demand for Coke increases, how would that shift the demand curve? If it increases, it would shift to the right. Right shift. Okay, so what we're talking about here is we have our price and our quantity, we have our demand shift, this would be our D. And now we're going to have our D2. It shifted to the right. And a little arrow. Okay, there are some other examples of substitute goods here for us. Hot dogs or hamburgers. So, you might think that for your cookout, hot dogs and hamburgers are good substitutes. You want one or the other. If the price of hot dogs goes down, your demand for hamburgers would go down because now hot dogs are cheaper. Another substitute, pencils or pens. So you need office supplies for school. You're going to buy the cheaper of the two. Coffee or tea, a Mac or a PC. If you need to ship something, UPS or FedEx. Any of these things could be substitutes, and you tend to choose whichever is the cheapest. So if the price of one goes up, the demand for the other will go up. The price of one goes down, demand for the substitute goes down. So your example in your notes, Nike and New Balance shoes are substitutes. If the price of Nike shoes falls, describe the shift to the demand curve for New Balance shoes. So if all other things were equal, but now Nikes are comparatively less expensive, people want to buy Nikes. So their demand for New Balance shoes will decrease. If it's decreasing, which way is it going to shift? It'll shift to the left. So here's our general rule. If the price of one good falls, the demand for the substitute also falls. These are directly related. If the price of one good rises, the demand for the substitute will rise. It will increase. So it is the opposite goods demand that is being affected in a direct manner. Now we're going to learn about complementary goods. So we learned about substitute goods. Now we're going to learn about complementary goods. These are also related goods, but instead of being purchased instead of other products, these are the and goods. These are being purchased together. They are bought as a set. So our example here is hot dogs and hot dog buns are complementary goods. You buy them together. So if the price of hot dogs falls, now that entire meal, that set, is cheaper than it used to be. So your desire to purchase all of it goes up. So if your demand for hot dog buns increases, it will shift to the right. Okay, so complements and substitutes are opposites of each other, because one is an or and the other is an and. Let's do some more examples. Coffee and creamer are an and. They're complements. You buy them together. If the price of coffee goes up, now your desire to drink coffee overall just went down. So your desire to purchase creamer, your demand for creamer went down. Peanut butter and jelly are complements. If the price of peanut butter goes down, your desire to buy everything just went up. Your demand for jelly went up. Printers and ink cartridges. If printers are on sale while you're at the store, you'll probably also now buy an ink cartridge. So your demand for ink cartridges increased. And shampoo and conditioner. If there's a brand where both of them go together and the price of shampoo goes up, you now might want to buy something else instead. So your demand for the partner, demand for the conditioner, will go down. Another example of complementary goods are tennis rackets and tennis balls. They go together. So if the price of tennis rackets rises, what happens to your overall desire to play tennis? It goes down. So your demand for tennis balls would decrease and it would shift to the left. A demand decrease is a left shift. Okay, so overall, here is our rule for complementary goods. When goods are complementary, there is an inverse relationship between price of one and demand for the other. So I hope you're noticing that complementary goods are opposite of substitute goods. So within this broader category of related goods, you need to think about, is this a complement or a substitute? Is this an and or an or? Because if it's a complement and they go together, when one costs more, your desire to buy all of it is now decrease. The price increase of one will have a decrease, an inverse relationship on demand for the other good. I stands for income, changes in overall consumer income. If consumers' income is going up overall, what would you expect to happen to demand? Now, this is an it depends answer because we actually have two different broad categories of goods that people can buy in society. So, income has two subcategories. There are normal goods and there are inferior goods. Normal goods is kind of a strange name because really this also includes luxury goods. Normal goods are the things that people want to buy, they demand, when their income is going up. Inferior goods are things that are not as good, they're inferior. So we're talking about the generic version, the store brand, the knockoff version of something that you only demand more of when your income is going down. So we'll talk about some examples. Taking a taxi is considered more expensive than taking the public bus down here. So the taxi would be the normal good, the public bus would be the inferior good option. Cooking ramen soup or going to McDonald's, does that sound like a normal good or an inferior good? Those are going to be less expensive options. So if we're in a recession and a lot of people are feeling like they have less income than they did before, the demand for ramen soup and McDonald's will increase because they're the inferior good. The normal good version would be a meal at a nicer restaurant, even a fine dining restaurant. But the demand for a meal at a really nice steakhouse, that's a normal good, that demand would go up when your income rises. Demand for a meal at a fast food restaurant, an inferior good, would go up when income falls. Shopping at a thrift store like Salvation Army, that's going to be an inferior good. Demand for vintage clothing and thrift store clothing goes up when income goes down. Demand for more expensive clothing from malls or from designers, those are normal goods, and demand for those goes up when income goes up. So changes in income is really an it depends. You have to decide, is the thing I'm looking at a normal good or an inferior good? Now I had a student ask, would this apply to services too? And yes, absolutely. So think about getting your hair cut. Is there a normal version of that and an inferior version of that? Yeah. So maybe going to a hair cuttery or a more inexpensive type of salon would be an inferior good, and going to an expensive hair salon would be a normal good. Your demand for the expensive hair salon goes up when income goes up. Your demand for hair cuttery goes up when your income goes down. Also, things like taking expensive trips. Maybe you'll fly to a tropical island when your income goes up, and you'll take a road trip to the next state over when your income goes down. Getting your taxes done, that's a service. So you might pay an accountant when your income is high, normal good. You might do your taxes yourself with some forms from the library, inferior, if your income goes down. The last shifter for demand is T, which stands for taste, or sometimes you could write it as trends. Either way, these are things that are popular in society. Our culture and our fads change all the time, and whenever something becomes more popular, the taste, the trend has risen, what do you think would happen to the demand for that product? It would increase. It would shift to the right. So maybe a sports team is doing really well, or a celebrity endorses a product. Any of those things could make the demand for it increase. If it's a brand new type of technology and everyone's really excited about it, it's going to become really popular and the demand will increase. But on the other side, things can also go out of style. Certain clothing trends, maybe they were popular a couple of years ago, but as tastes change, the demand for those products will start to decline. They'll shift to the left. Next, we're going to practice drawing demand shifters for 4 different products. You are going to need to use the shifter to explain why that line shifted. Now we're going to practice doing some of the demand shifters. So I thought we would do the first one together just so that you're setting up all of the labeling properly. And then you'll go ahead and do the next 3 on your own and we'll check your work at the end. The first situation or scenario says, average salaries fall. Illustrate the effect on the demand for Rolex watches. So here we have P labeled because P is always going to stand for price, and price goes on the y-axis. So make sure that on the edge of the y-axis you write P, and then quantity goes on the x-axis, so on the edge there you're going to write Q for quantity. And demand is always downward sloping because as the price falls, people demand more. So also it's important to see the demand doesn't actually touch either side. It kind of floats in the middle. Very few, if the price is the highest possible, people would buy 0. We don't hit the lines there, so it floats. So go ahead and draw a D like that, and then you're going to label it D for demand. And the last labeling you'll need is the name of the good. So in this situation, the good we're focusing on is Rolex watches, so you have to write that on the top. Okay, once you've labeled everything, let's read the scenario again. Average salaries fall. Illustrate the effect on the demand for Rolex watches. So our options are demand increased, which would shift to the right, demand decreased, shift to the left, or we could have a move along the curve, and that's dependent on what thing changing. If price changes, you have a move along the curve. So keep in mind there's 3 possible options. Price change, which is a move along the curve, or an increase or a decrease. Also, for the reason, those are going to be the 5 categories of merit. Market size, expectations, related prices, income, and taste. And 2 of those categories have subcategories. So if your reason is about the related goods or related prices, you're going to need to say related goods dash substitute or dash complement. And then income also has 2 categories. So income change dash normal good or income change dash inferior good. So keep in mind what all your possible options are. Once you've decided what happens on this one, do we think demand is increasing, decreasing, or move along the curve? If average salaries fall, that's going to be a demand decrease. So you want to have demand on the left side. It's shifted to the left. So it says D2 with an arrow pointing towards D2. And then your reason is income. And because that one has a subcategory, you have to specify that Rolex watches are normal goods. You only buy those when your income is high. One thing to point out here, you might think, why is she saying it's a left shift and not it just shifted down? Well, because in other models, lines will go in opposite directions, and decreases always shift to the left, but not necessarily down. So I'm trying to set up the foundation of what you're going to need for future models. So make sure that you're never saying up or down. Decrease is a left shift and increase is a right shift. Now go ahead and take some time to read the situations, label price, quantity, the demand curve, and write the name of the good at the top. And then go ahead and attempt to do the shifts and the reasons on your own. Pause this video, then we'll check your answers when you're done. So now we've had some time to work on the other 3 examples, so let's go through and check and see how you did. So the first one says, the price of Miracle Whip falls. Illustrate the effect on the demand for mayonnaise. So I went ahead and set up price, quantity, demand, but I left the product name blank because part of the difficulty here is determining which product are we drawing here. Are we drawing Miracle Whip or are we drawing mayonnaise? The question is saying the effect on the demand for mayonnaise. So that's the model that you draw. If you drew Miracle Whip, it would be a whole different model Because for Miracle Whip, if the price of it is falling, that means that you would have a move along the curve on the demand curve for Miracle Whip. Mayonnaise, how is that related to Miracle Whip? Is there any connection between them that you can think of? Because that's the key to answering this question. So, Miracle Whip and mayonnaise are related goods. They are substitutes. You would buy one or the other. So, if the price of Miracle Whip falls, a substitute for mayonnaise, you would decide to buy Miracle Whip because it's now the cheaper alternative. So if one of them is cheaper, the other one, the substitute, mayonnaise, the demand for it would decrease. So we have a left shift to the mayonnaise curve because they're related substitute goods. All right, go ahead and pause this one if you need more time. I'm going to go on to the next one. Here we have the price of apples rises. Illustrate the effect on the demand for apples. So here we have price, quantity, demand for apples. What do you think is happening? Demand increase, decrease, or move along the curve? It's a move along the curve because the price of the thing has been affected. So it wasn't the price of something you'd buy instead or with apples. It is just the price of apples. So the reason is this is a move along the curve. It's a price change. And anytime you have a move along the curve, you're going to do two dots on the line anywhere. Doesn't matter where you start, but the arrow direction is important. If the price is rising, you want the arrow to be pointing towards the price increasing. The price at the new location is higher than the price of the original one. You're not going to write D2 anywhere because D2 stands for a new demand line, and we don't have one. It's the exact same. So this is all you need to show the move along the curve. If you need more time, pause it. If not, here's our last example. The Nationals make it to the World Series. Illustrate the effect on the demand for Nats hats. So we have price, quantity, demand, and Nats hats the good. What do you think is the shifter here? What is the effect? And which way will demand move? Okay. This is about taste. If the Nationals make it to the World Series, then they're going to be more popular. And when popularity increases, that's going to make demand rise. So we have a right shift, D2, and the arrow pointing in the direction of the shift. So hopefully that went well and you're starting to understand demand and demand shifters.